the pump may have developed a leak that is causing electrical current to flow into the water. This leakage current can trip the ground fault interrupter receptacle when it exceeds 5 mA. Although the time clock was replaced, it is possible that it's still malfunctioning. It could be intermittently drawing excess current or creating a ground fault. The new ground fault interrupter receptacle may be more sensitive than the previous one. This could cause it to trip even with a small amount of leakage current. The greenish color of the water suggests that algae or other contaminants may be present. These contaminants can increase the conductivity of the water, making it easier for leakage current to flow. The pump time clock and ground fault interrupter receptacle may be drawing excessive current, causing the circuit to overload and trip the ground fault interrupter. If possible, remove the pump from the water and inspect it for any damage, cracks, or rust. Check the electrical connections, then ensure they are tight and secure. Install a new time clock and observe if the tripping issue persists. Use a ground fault interrupter tester to ensure the receptacle is functioning properly. If the tester indicates a fault, replace the receptacle again. Treat the water with an algaecide or other water treatment solution to remove contaminants. This may reduce the conductivity of the water and prevent leakage current. Use a multimeter to measure the current draw of the pump, time clock, and ground fault interrupter receptacle when they are all operating. If the current exceeds the rated capacity of the circuit, it may need to be upgraded. Make sure the pump is not submerged deeper than its rated depth. Ensure that the electrical cord is not damaged or frayed. Consider installing an additional ground fault interrupter outlet in series with the existing one to provide redundancy. If the problem persists after following these troubleshooting steps, it may be necessary to replace the pump. To expand on these points, let's delve into the technical details that might be causing the ground fault interrupter to trip in the fountain setup. Firstly, pump leakage current is a common culprit in submersible pumps. Over time, the insulation around the pump's motor windings can degrade, leading to a path for current to leak into the surrounding water. Ground fault interrupters are designed to detect very small imbalances in current between the hot and neutral conductors, typically around 5 mA as was mentioned earlier. If the leakage current exceeds this threshold, the ground fault interrupter will trip, cutting off the power to prevent electrical shock. The age of the pump, approximately 3 years, doesn't necessarily guarantee its reliability, as environmental factors and manufacturing defects can accelerate insulation breakdown. Secondly, even though the time clock has been replaced, there's a chance the new one could be faulty or incompatible. A malfunctioning time clock might introduce harmonic distortion into the electrical circuit, which can confuse the ground fault interrupter and cause it to trip. Harmonics are essentially extra frequencies that ride along with the normal 60 Hz alternating current, and they can create ground currents that the ground fault interrupter interprets as a fault. Also, a time clock with a poor internal design might create a direct ground fault if its internal component short to the enclosure. Thirdly, ground fault interrupter receptacle sensitivity varies between different models and manufacturers. Some ground fault interrupters are designed to be more sensitive to leakage current than others. A more sensitive ground fault interrupter will trip more readily, even with a very small leakage current. It's possible that the new ground fault interrupter receptacle is simply more sensitive than the old one, leading to more frequent tripping. Ground fault interrupters also have a limited lifespan and can become more prone to nuisance tripping as they age. Fourthly, water contamination plays a significant role in leakage current. Water with high levels of dissolved minerals, algae, or other contaminants becomes more conductive. This increased conductivity allows leakage current to flow more easily from the pump into the water and back to ground. The greenish color of the water suggests the presence of algae, which can significantly increase the water's conductivity. The conductivity of water is measured in microsiemens per centimeter, and even a small increase in conductivity can dramatically increase leakage current. Fifthly, an electrical circuit overload can also cause the ground fault interrupter to trip. If the pump, time clock, and ground fault interrupter receptacle are drawing too much current, the circuit breaker protecting the circuit might trip. However, if the overload is not severe enough to trip the breaker immediately, it can create a voltage drop in the circuit. This voltage drop can affect the performance of the ground fault interrupter, making it more susceptible to tripping. The total current draw of all devices on the circuit should be well below the circuit's rated capacity. Let's move on to the troubleshooting steps. Firstly, inspecting the pump involves a thorough examination of its physical condition and electrical connections. Before removing the pump from the water, disconnect the power supply to prevent electric shock. Once the pump is removed, look for any signs of physical damage, such as cracks, bulges, or corrosion on the pump housing. Pay close attention to the area where the electrical cord enters the pump, as this is a common point of failure. Check the electrical connections inside the pump's junction box to ensure they are tight and free from corrosion. Use a multimeter to measure the resistance between the pump's electrical conductors and the pump housing. A low resistance reading indicates a leakage path. Secondly, replacing the time clock with a known good unit is a simple way to rule out a faulty time clock. Ensure the new time clock is compatible with the pump's voltage and current requirements. After installing the new time clock, monitor the system to see if the tripping issue persists. If the tripping stops, the old time clock was likely the problem. Thirdly, testing the ground fault interrupter receptacle with a ground fault interrupter tester is essential to ensure it's functioning correctly. A ground fault interrupter tester simulates a ground fault condition and verifies that the ground fault interrupter trips within the specified time. If the ground fault interrupter fails to trip when tested, it's faulty and needs to be replaced. Ground fault interrupter testers are readily available at most hardware stores and electrical supply houses. Fourthly, cleaning the water is important to reduce its conductivity and minimize leakage current. Algicides and other water treatment solutions can kill algae and other contaminants that increase the water's conductivity. Follow the manufacturer's instructions carefully when using water treatment solutions. Regularly cleaning the fountain and replacing the water can also help prevent the buildup of contaminants. Fifthly, checking the electrical circuit involves measuring the current draw of each device in the circuit. Use a clamp meter to measure the current flowing through the circuit's conductors while the pump, time clock, and ground fault interrupter receptacle are operating. Compare the measured current to the circuit's rated capacity. If the current exceeds the rated capacity, the circuit is overloaded and needs to be upgraded. Overloaded circuits can create a fire hazard and should be addressed immediately. Now let's discuss some additional considerations. Firstly, submersible pumps have a maximum rated depth to which they can be submerged. Exceeding this depth can damage the pump and create a safety hazard. Check the pump's specifications to determine its maximum rated depth and ensure it's not being exceeded. Secondly, a damaged or frayed electrical cord can create a path for leakage current. Inspect the cord for any signs of damage, such as cuts, abrasions, or exposed wires. Replace the cord if any damage is found. Use a cord that is rated for outdoor use and is resistant to water and sunlight. Thirdly, installing an additional ground fault interrupter outlet in series with the existing one provides redundancy. If one ground fault interrupter fails, the other will still provide protection. This is a simple and inexpensive way to increase the safety of the fountain setup. However, it's important to note that installing multiple ground fault interrupters in series can sometimes lead to nuisance tripping. Finally, if the problem persists after following these troubleshooting steps, it may be necessary to replace the pump. A pump that has developed a significant leakage current may not be repairable. Replacing the pump with a new, high-quality unit is often the best solution in this case. Be sure to choose a pump that is specifically designed for fountain use and is rated for continuous operation. Also, grounding is absolutely vital for electrical safety. The grounding system provides a low impedance path for fault current to flow back to the source, which causes the circuit breaker to trip and energizes the circuit. This prevents dangerous voltages from appearing on metal parts of electrical equipment. In the case of a fountain, if the pump develops a fault, the fault current will flow through the grounding system, tripping the circuit breaker and preventing electrical shock. The grounding system consists of a grounding electrode, such as a ground rod or a metal water pipe, which is connected to the electrical panel. From the electrical panel, a grounding conductor runs to each outlet and piece of electrical equipment. This grounding conductor provides the low impedance path for fault current. It's essential to ensure that the grounding system is properly installed and maintained. The connection should be tight and free from corrosion. The grounding electrode should be buried deep enough to ensure good contact with the earth. Regularly inspect the grounding system to ensure it's in good condition. Another crucial aspect of electrical safety is proper wiring practices. Use the correct wire size for the circuit's amperage rating. Undersized wires can overheat and cause a fire. All electrical connections should be made inside approved junction boxes. These junction boxes protect the connections from moisture and physical damage. When running wires outdoors, use weatherproof conduit and fittings. This will protect the wires from the elements and prevent them from becoming damaged. Always follow the National Electrical Code (NEC) when installing electrical wiring. The National Electrical Code provides detailed guidelines for safe wiring practices. The National Electrical Code covers everything from wire size and insulation to grounding and bonding. It's essential to be familiar with the National Electrical Code and follow its guidelines when working with electricity. Failure to follow the National Electrical Code can result in serious injury or death. Furthermore, surge protection is often overlooked but can be beneficial in protecting electrical equipment. Surges are transient over-voltage events that can damage or destroy electronic components. They can be caused by lightning strikes, power outages, or even switching of electrical equipment. Surge protectors are designed to divert these surges away from sensitive equipment, protecting them from damage. There are several types of surge protectors available, including whole-house surge protectors and point-of-view surge protectors. Whole-house surge protectors are installed at the electrical panel and protect the entire home from surges. Point-of-view surge protectors are plugged into outlets and protect individual pieces of equipment. It's a good idea to use both types of surge protectors for maximum protection. Also, GFCI protection is a critical safety feature for any electrical circuit that is located near water. Ground fault circuit interrupters are designed to detect very small imbalances in current between the hot and neutral conductors. If an imbalance is detected, the GFCI will trip, cutting off the power to prevent electrical shock. Ground fault circuit interrupters are required by the National Electrical Code in areas where there is a risk of electric shock, such as bathrooms, kitchens, and outdoor locations. They can be installed as receptacles or as circuit breakers. It's a good idea to install ground fault circuit interrupters on all electrical circuits that are located near water. When troubleshooting electrical problems, it's essential to use the right tools and equipment. A multimeter is an indispensable tool for measuring voltage, current, and resistance. It can be used to check for voltage drops, continuity, and shorts. A clamp meter is used to measure current without having to disconnect the circuit. An insulation tester is used to measure the resistance of insulation. It can be used to detect insulation breakdown. The ground fault interrupter tester is used to test ground fault interrupter receptacles. It's important to use these tools safely and correctly. Always follow the manufacturer's instructions. Wear appropriate personal protective equipment such as safety glasses and gloves. And never work on electrical equipment while it is energized. If you're not comfortable working with electricity, it's best to call a qualified electrician. Electricians have the training and experience to safely diagnose and repair electrical problems. Attempting to repair electrical problems yourself can be dangerous and can even be illegal. Always hire a qualified electrician for any electrical work that you're not comfortable doing yourself. In the context of the fountain, consider the impact of hard water. Hard water contains high levels of minerals, such as calcium and magnesium. These minerals can deposit in the pump and other parts of the fountain, reducing their efficiency and lifespan. Hard water can also increase the conductivity of the water, making it more likely for leakage current to flow. If you have hard water, consider using a water softener to reduce the mineral content. Water softeners remove calcium and magnesium from the water, making it softer. This can help prolong the life of the pump and other fountain components. In addition, proper wire management is crucial for maintaining a safe and reliable electrical system. Keep wires neatly organized and secured. Use cable ties or other fasteners to prevent wires from becoming tangled or damaged. Avoid running wires across walkways or other areas where they could be tripped over. When running wires through walls or ceilings, use proper grommets to protect the wires from abrasion. And always label wires clearly so that they can be easily identified. Also, consider the effects of temperature on electrical equipment. Electrical equipment is designed to operate within a specific temperature range. Exceeding this temperature range can damage the equipment or reduce its lifespan. In hot weather, electrical equipment can overheat. This can cause insulation to break down and can even lead to a fire. In cold weather, electrical equipment can become brittle and can crack. This can also lead to insulation breakdown and electrical shorts. To protect electrical equipment from temperature extremes, consider using enclosures that are rated for outdoor use. These enclosures are designed to protect the equipment from the elements. And be sure to keep electrical equipment clean and free from debris. Dirt and dust can trap heat and can also reduce the insulation value of electrical components. Furthermore, regular maintenance is essential for keeping electrical equipment in good condition. Inspect electrical equipment regularly for signs of damage or wear. Check for loose connections, frayed wires, and cracked insulation. Clean electrical equipment regularly to remove dirt and dust. Lubricate moving parts as needed. And replace worn or damaged parts promptly. By following a regular maintenance schedule, you can prolong the life of your electrical equipment and prevent costly repairs.